me see here. I'm going to give you a break at some point, so I don't want you to worry about that. We'll probably take a break around maybe 2:30, 2:20, 2:30, around there. Okay. So let us continue. So there's three ways that we can represent a function. The first way is using a table of values. We don't do this very much in this class. We do this to sort of help us graph things. Like we'll create a table and then plot a bunch of points at first just to get a rough idea of the shape of a graph. Okay. The second way is we use function notation. So we use a formula. And that's the way that you guys are used to seeing things. So for example, you guys something like f of x is equal to 1 over the square root of x minus 1, something like that. Okay. And then the third way we have is we use a graph. Some books also give a verbal description, but we don't really do that in this class. Okay. So there's an easy way to check if something is a function. And when you're looking at the graph situation, well, let me talk about the table situation first. Sorry, so let me back up. So if we talk about the table situation, let's say that I described f of x like this. So let's say you have 1 goes to 7, 2 goes to 24, 3 goes to 8, and 1 goes to -6. Does this table correspond to a function? No, why not, Alice?
Because the x value can have two outputs, so it, like you said, it exactly one output value.
Correct. 1 goes to 2 different values. Okay. All right. So you know, that's one way you could tell if you had a function. You can look at a table of values, and you know, if sort of you have one input value having 2 output values, it's not going to be a function, as Alice just said. Okay. As far as the graphical part, there's something called a vertical line test. Students love the vertical line test, right? So it's abbreviated VLT. And the vertical line test basically says a graph corresponds to a function if every vertical line intersects the graph at most once. Okay. So, you know, I could just draw a picture to show you. If you have something that looks like this, sorry, that's ugly. And then we draw a graph that looks like this. This guy fails the vertical line test, right? So we draw a vertical line. Ugh, that's not vertical. Try to, So you see how it crosses at 2 points, fails vertical line test. Not a function. That make sense to everybody? Just out of curiosity, do you guys know the equation of this graph? Does anyone know?
x is equal to y squared.
Correct. So remember how I was saying like, oh, you can, you know, this whole stuff always is assuming that x is the independent variable. But if we switch it around, if we say, you know what, y is the independent variable, then you turn your head sideways. And then it's almost like it would pass the vertical line test with your head turned sideways. So it really matters which one's the independent variable. Okay. All right. So a little bit more notation. The zero of a function is the zero of a function are the points. The zero is the point. It could be more than one point where the function sorry. I want to be more specific. It's not just points, they're really the x values. Let me erase this. Say the x values where the function is equal to 0. This is also called the X-Intercepts. Intercept means to cross, right? So the zeros are also called the intercepts, okay? And to find the 0, all you got to do is you set f of x equal to 0 and solve for x. So it's pretty straightforward. Okay. To find the y-intercepts, what do we do? To find the y-intercepts, you set y equal to 0 and solve for x. Wait, set x equal to 0 and solve for y, sorry. X equal to 0 and solve for y. All right. So let's find the zeros, y-intercepts, and we won't worry about sketching the graph because we're going to learn about transformations of functions today, or hopefully, maybe. So we'll go over that later, the graph part. Okay. So to find the zeros, we're going to have to find the zeros, we set it, the function equal to 0. So we got 0 is equal to the square root of x plus 2 minus 1. Then we're going to add 1 to both sides. This is 1 is equal to the square root of x plus 2. How do we undo the square root? Well, we're going to square both sides. So we square this guy and we square this guy. And then this tells us that we get 1 is equal to x plus 2. And this tells us that x is equal to -2. Wait, I just somehow wrote x plus 3 there. Sorry. So we subtract 2 for both sides. And we get x is equal to -1. To find the y-intercepts, do the opposite. You got y is equal to the square root of x plus 2 minus 1. And we plug in a 0 for x. So we got y is equal to the square root of 0 plus 2 minus 1. So then this means that y is equal to the square root of 2 minus 1. So these would be our answers. Does that make sense to everybody? Any questions? All right. Okay, so let's define a couple of terms here, and then and then we'll take a break. Okay. So we want to know when our function is increasing and when our function is decreasing. So I think intuitively, it means the function goes up as you move from left to right. But that's not really a mathematical definition. So I want to write down the intuitive definition first. So let's say, or not definition, but I'm going to say intuitively, the function goes up as x increases, right? Up like this. So like if you're buying stocks and they chart the price of the stock, you want it to be increasing. You want to see it kind of go greater and greater as time passes, right?
Professor,
Mm-hmm.
can you scroll up a little? Because I think I missed something. Okay, never mind. Thank you.
Mm-hmm. So, how do I put this? The further and further you go in your mathematical journey, the more and more important the idea of a definition is. So, so for our definition, we want to define things very precisely in mathematics. And sometimes the definition doesn't exactly look pleasant, or it doesn't match your intuition, even though it means the same thing. So let me define this for you. So a function is increasing. First of all, we define increasing to be on an interval. Right now, we don't just look at a point and say whether it's increasing or decreasing or not. We sort of look on some sort of interval, and on that interval, we could say, does it look like it's going up or does it look like it's going down? Okay. So basically, you take 2 points in the interval, x1 and x2, and we're going to say, let's say that x1 is less than x2. So that means x1 is on the left and x2 is on the right. Okay. So if this is true, then this is called an if-then implication. Then what does that mean? Well, if I want to say that my function gets bigger and bigger, then basically that's going to mean the function value at x1 is going to be less than the function value at x2. Okay. So if I were to draw a picture to show you that, right? So let's say x1 is here and x2 is over here. What we're trying to say is, let's say if this guy is x1, f of x1, then when I look at x2, the y value should be higher, right? So if I come over here, this is x2, f of x2. So can you see that when x1 is less than x2, f of x1 is less than f of x2? That's what increasing means. And this whole if-then situation, oops. This whole if-then situation right here, this is called an implication. And it basically, we write it like this. We say, if x1 is less than x2, the then part, you put a little arrow to mean it implies that f of x1 is less than f of x2. Okay. Is there any questions about that? So at this point, I just want this definition to make sense to you. Like, we don't really need to use it for anything, but it turns out that we're going to define something called a limit precisely later. And we're going to define something called a derivative very precisely later. And I need to use these words and stuff, and use this notation, and use this implication idea. So decreasing, well, it's another if-then statement. If x1 is less than x2, then what happens this time? Well, this time, if it's decreasing, the function value at the left point should actually be greater than the function value at the right point like this. So we could write this as x1 is less than x2 implies f of x1 is greater than f of x2. And I'm going to do that thing where I just copy this picture, paste it here. Let me move this guy up a little bit. Let me move this guy down a bit. I should probably have a graph. So you see, it's getting bigger and bigger. It's getting smaller and smaller on that interval. That makes sense to everybody? Is there any questions?
Is the inequality symbol supposed to be flipped? Or did I miss something? For the x1 and x2 on the decreasing one. Because it
For
says,
this first part right here?
yeah.
So I want to keep it the same.
Okay.
In other words, x1 is less than x2. The one that I flip is this one.
Oh, okay, okay.
Because instead of going up, it now goes down. So the first one should be bigger than the second one.
Okay.
Mm-hmm. Any other questions? All right. So let's take a break.